Hello everyone. Am I audible? Can you just bring in the comments? Uh, this is my first session. I missed the last week. You can find the other sessions in our YouTube channel. And I continue with this. If you have the knowledge of machine learning, yes, you can definitely continue with this. Just give me a minute and we'll begin shortly. Okay then. So far in the week one, what have we learned? Just drop in the comments anyone who's familiar with what we have done in the week one, who attended week one. So we went into the basics of Python. Then we also went into basics of pandas. We got an intro into ML, what is machine learning. We also looked at what is supervised learning. Anyone who remembers what supervised learning is, just drop in the comment section. Basics of pandas, Python and pandas, yes. A small definition of what machine learning is or what supervised learning is. Anyone who remembers from the previous sessions, please drop them in the comments. No one. Label data. Okay. Anyways, so this is week two. Let's look into what is there for today, the first session of week two. So we'll be covering regression, what is linear regression, an example of linear regression. Then we'll be going into intermediate machine learning, that is basics of unsupervised learning. What is unsupervised learning? The basics of unsupervised learning. Then we'll be looking at clustering, what exactly clustering is. Then after that, we'll also be looking into some code to understand how clustering works. Is it clear? Okay, we train model using labeled data, supervised learning. Yes, that is true. We have data in organized manner, which we use to predict or classify. Yes. Any guesses what regression is? We did see about classification. What regression is? Prediction is equal to regression. Okay. We'll see further what exactly regression is. Anyway, so just to refresh everyone's memories, this was the agenda. So today we'll be looking at intermediate machine learning, how to bridge the learning gap. So we'll be taking sessions. This was already covered in the previous sessions, but for people who are new, we'll be taking sessions on the weekends, and then you'll be given assignments. You can go learn on the Kaggle, clear your doubts in the AMA. We'll be having an AMA session tomorrow with Moin, and then you have to practice the given tasks. And well, practice makes a man perfect. So keep on practicing. So for today's session, these are the things that you should actually be learning from Kaggle. This is your self-study. And then we'll also look into what we'll be covering. So categorical variables, classification, cross-validation, boosting algorithms. These four things you'll have to learn from Kaggle by yourself. Uh, and then resources will obviously be shared. So you don't need to worry about that. Resources will be shared as to what you will have to learn. So for now, let's get started with the topics that I have said previously. We'll start with regression. Then we'll also look into linear regression. We'll look at an example of linear regression. Then we'll go into unsupervised learning. And in unsupervised learning, what is clustering exactly? And then some code to understand what clustering is. Is that clear? Cool, everyone. Just drop a thumbs up in the comments. Don't see any thumbs ups. Clear. Okay, let's proceed then. So, what does regression means? Basic textbook definition: regression is a process of finding the correlations between dependent and independent variables. It helps in predicting the continuous variables such as prediction of market trends, prediction of prices, etc. The task of regression algorithm is to find the mapping function to map the input variable x to the continuous output y. Now, this might be a bit confusing as like textbook definitions usually doesn't go well into our head. So in simple terms, what regression is, we discussed about variables previously, right? So here's just a small example. Imagine you're trying to figure out how much time you need to study to get a good grade on a test. If you study little, you might expect a little grade, a certain little grade. But if you study more, you might expect a better grade. So that is what regression in machine learning is like. Like it's a curve. Basis on the x variables that are the dependent variables, they're dependent on the independent variables. So these independent variables and dependent variables, like uh, the time that you study is a dependent variable over here, and then the grade you get is an independent variable. So the more you study, the more better grade you get, the more better chances you have to get a better grade. That is how this works. In simple terms, that is how linear regression is. So this is an example of Indian rupee, like the year and how much it valued in the international markets. Now, these graphs might be confusing. So I'll just show another example. I'll show a code as to how this exactly works. This Indian rupee system. This is data taken from Google over the period of time, how much Indian currency in the international market have increased or depleted. So let's look at the code. Okay. So as we are doing a Kaggle certification, this code is also done in Kaggle notebook. Everyone with an account in Kaggle can open the code section, and the code section will be on the left. Then you can click on a new notebook and you'll find a notebook where you can perform your machine learning assignments or any tasks that you also want to do. So let's start by importing NumPy. This is the simple code of linear regression. Let's start by importing NumPy, and then we are also importing matplotlib, and we'll look into this, why matplotlib as pyplot specially. Then we are also importing SkyPy. So first look at our data over here. So this was the data. This is the X and this is the Y that we discussed previously in the linear regression. This X is what we have taken as years, and then uh, 0, 1, 2, 3 is being represented as years. And the prices is another section that we have taken off from the similar data in the previously shown table. Now to perform linear regression, we are using slope and intercept because the line of the linear regression as seen in this example of linear regression, this line have a slope as every line does. Yeah. So intercept and R value, P value, standard error. These are few metrics that we are using. And then we are using R squared to check the accuracy of our model. After that, we are printing all of these values. We're generating a slope and a regression line for the slope. Now, these values are being fitted into the model. After that, to understand the model, we are also creating a plot. To create this plot, we are using Matplotlib, and we're using a figure size. We are giving the colors of the plot. The color label is for the actual data and label actual data. Then we're using a color red for the label regression line. On the X line, we're using years. You can see over here. So this is basically a plotting techniques. After we plot on the X, Y, we give it a title, we give year labels, and then we plot it. Over here, you can see the accuracy. So this model have an accuracy of 92%, 92.81. This should actually be multiplied by 100. And this is how the simple linear regression of this example is. The example that we saw over here. This code will also be shared with the resources, so you can run it in your own notebooks. Price versus time, a simple linear regression. So as you can observe over here, as the year is increasing, the price of the rupee is also increasing simultaneously with it. Could you share the input data in the chat so we can follow along? The data will be shared later. It is difficult to share at this point. We'll definitely share you in the after this live, so you can practice along. Anyways, till here, is it clear? Just drop a thumbs up if it's clear till here. Crystal clear. Uh, okay, that's good. Okay, then let's proceed to unsupervised learning. So, what is unsupervised learning? Anyone with guesses what unsupervised learning is? Please drop them in the chat box. Any guesses what unsupervised learning is? Mm, how to do assign unorganized data? Okay. Regarding how to do assignments, we'll take this was already taken up. You can refer the previous sessions if you don't understand it, or you may join the AMA session and that will be held tomorrow to clear any doubts you have. Untrained or only raw data is provided to the machine. Yes, untrained data. Okay. Uh, okay. Anyways, so I'll start. A textbook definition. Unsupervised learning is a type of machine learning that deals with data that has no specific predefined labels. Unlike supervised learning, we know the target outcome or labels in advance. So unsupervised learning tries to hide hidden patterns or intrinsic structures within the data. Now, in simple terms, for supervised learning, we have different labels in the data or the different columns. Like when we look at this table, okay, we have a time and we have price. These are labels of the data. But when we look at unsupervised learning, that might not necessarily be the case. Now, in unsupervised learning, there are majorly two types are considered. One is association and the other one is clustering. Like if we are just going into the basics, that is what is being said. And similarly for supervised learning, as classification and regression are there, for unsupervised learning, we have association and clustering. So let's look at what clustering means. So a textbook definition again, clustering is a process of grouping a set of data points into clusters, where points in the same clusters are more similar to each other than to those in other clusters. It helps in identifying natural groupings within the data, such as customer segmentation, document clustering, and anomaly detection. So, in simple words, if I have to explain what clustering is, okay, we'll take an example and understand what exactly in a better way clustering is. Imagine you are hosting a party and a group of want to group guests based on their conversations or maybe their hobbies or the things that they like to talk about more. So if we just look at a party, I mean, everyone loves parties, right? If we look at a party, there'll be different types of people. Some people, they like to talk about music, while others, they may be into esports, or some might be into sports, physical fitness. Now, you group these people naturally. So if we look at this previous diagram, suppose the blue dots over here are the people who like music. The red dots are the people who like watching movies more. So these are movie enthusiasts. And then the green dots might represent the people who are into esports. So when we look at the data, we generally are not given a label for these people. So what we do, we form clusters. Clusters is grouping these people together. And as you can see from this data as well, this will be a cluster. This will be the main title, like people in party, and then this data over here that you can see, this data might represent people who are into music, this might represent who are into esports, this might represent people who are into movies, and then this might represent people who might be wanderlists, people who like traveling. So that is clustering in simple terms. Any doubts, any questions regarding clustering? Great explanation. Thank you. Any other questions that you have regarding clustering, please feel free to ask in the comments. How would clustering work for data in or of string? Sorry, I did not get your question. But we'll look into an example so that might clear your doubt. Okay, then I'll just share the example of it. Yep. So is my Kaggle notebook visible? Just drop a thumbs up in the comments if my Kaggle notebook is visible. Okay, cool. So we'll be looking at an example of clustering, and specifically in clustering, we'll be looking at an algorithm called k-means. Just like in regression, how we had linear regression, an algorithm, we'll look into k-means as an algorithm in clustering. So for that, what we're doing is we're importing pandas first. You know what pandas is, right? We have done pandas in the previous sessions. So after that, we're using a library called sklearn or scikit-learn. Then we're using sklearn dot dataset. So this is actually used to import a dataset. So for this clustering, we're actually using a well-renowned dataset. If anyone is into machine learning, they might have known Iris dataset. Please drop a thumbs up or a like if you know what Iris dataset is. Anyone familiar with the Iris dataset? No one? Flower dataset. Yes, it's a flower dataset. Yes. Others familiar with Iris dataset? Drop a thumbs up. Okay, cool. No issues. So basically, iris dataset represents flowers. It's a species of flower, and in that we again have three species. Anyways, so moving on, we need to know what the data set that we're using is so that we can also perform further operations on it. So moving on, and similarly, we're using matplotlib again to plot the data. Now, why are we plotting the data? Like, why is it important to plot the data every time? So I'll just share the linear regression examples. As we have seen over here, if you just see the code this much, okay, you won't see the plotting. You'll not understand. You will understand the accuracy of the model, but you won't get a clarity as how your model is performing or how the data is being actually trained on the model or not. So to get a better clarity, we're looking at the visual representation of it. That is why we're plotting. So this is how plotting helps. Anyways, coming back to clustering, using matplotlib to plot again. We're using import warnings. So import warnings is a library used to avoid all the warnings that occur. These warnings might not be that important, but they'll just cause a bit distraction. So just to avoid that, we're using import warnings and we ignoring the warnings. Now, the first and most important step is we imported our data, iris. So we're just loading the data. We're loading the data using pandas. Okay. Uh, pd dot data frame. A data frame is a function in pandas. So we are storing it in a variable df. After loading the data, as I said, it's important to understand the data. We are using df.head to understand what do we have in the data. So from here, as you can see, we have sepal length, sepal width, petal length, and petal width. So what is sepal length? What is sepal width? And what is petal length? What is petal width? Anyone who knows the answer? Yes, we'll definitely be sharing the codes. I'll definitely share the codes after this session for practice. In the meantime, anyone have an idea about what is sepal length over here, sepal width, or basically what is a sepal or a petal? Biological parts of a flower. Yes, that is an answer true. Any other answers? Anyways, so basically every flower have a petal to it, a sepal to it. So a collection of sepals and petals become a flower. In simple terms, if I have to explain you. And why is this important? It is important so that we understand what data we are working on. If we understand what data we are working on, then we might able to get better insights out of it. So the in simple terms, that is a sepal and a petal. So what we are doing over here is we're seeing just the head of it. Head will give you the first five values, rows basically, not values, but the first five rows of a data. Now, looking at this, we can have an understanding. Okay, we have sepal, its length, its width, and we have petal, its length and its width. And as I previously said, if you are familiar with the dataset iris, you will also know that there are three species in iris. Now, I won't get into much detail regarding that, but in simple terms, there are three species in iris. So, iris flower. So what we are doing is we are using the k-means algorithm and we are forming three clusters. Why three clusters? Because as we already know now that there are three species, as we already know now that there are three species in the data, will be taking three clusters. And if you know that there are more species and all, then you can definitely go for more. What we are doing, we're using k-means algorithm and we're fitting the model. Why are we fitting the model now? Why are we using dot fit? That is because of that is because we want to train the data that we have in the k-means algorithm. So for that we are using dot fit, and then next we'll be moving into prediction. So this is very easy because we want to do the prediction. And to understand this more again, as covered previously, we'll be plotting it. We'll be plotting using matplotlib dot pyplot. So PyPlot is actually a sub-library inside Matplotlib. We'll be plotting using that. And this is how we are plotting the sepal and sepal length, the sepal width. Then we'll be using X label and Y label, X label for this and Y label for the Y axis. Title is simple. K means clustering of iris flower. And then plt.show to show what we have plotted. So as you can see from this diagram, we see three different colors. One is sea green, one is purple, and one is yellow. So each color represents a species of iris flower. And this is how clustering is done. Now, by looking at this diagram, you can make out that these sea green color uh, data, all these sea green color data types, these represent one species, and these purple, they represent another species, and these yellow dots, they represent another species. Now, you might be seeing some data sets that are overlapping, some like this dot over here between 4.5. So these concepts will probably look in further sessions like outliers and all. Maybe in feature engineering, it would be covered. But for now, this is a simple example of how clustering is. Any doubts in this till here? Also, if anyone over here is actually very curious as to what this warnings will do, so I'll just give a demonstration of it. I'll run the code after commenting out the warnings. Okay. Anyways, it did not give me any warnings over here now. So that's actually a very good thing. But generally, it does give warnings, and those warnings are really annoying. Yep. Anyways, any doubts over here? No doubts, no questions? And the code will be shared on the WhatsApp. Yes, we'll definitely share the code. No more questions, no more doubt. Okay, cool then. So let's proceed further. This was all about clustering. And yep, for the AMA session will be held tomorrow. It would be taken by Moin, who was taking the first and second sessions. Anyways, that's it for today then. Till now, we've covered intro to machine learning. We've covered pandas as well. Intermediate machine learning. This was intermediate machine learning, the clustering and the supervised learning. This would also be taken and discussed further as well. And then tomorrow's session will be on feature engineering. If anyone have any questions now, anything you would like to add, you may drop down in the comment section. Okay, then I see no questions. So thank you all for joining. It was a great audience. Wonderful to have you all. Very good evening. Bye, everyone. Wait, we got a question. Google Colab or Kaggle, which would be better? Both of them are cloud platforms, so you can go with any of them. And it would not be wrong to choose either of those. But some resources in Kaggle, for example, the RAM that you get in Kaggle is more than what you get in Google Colab. So for some things, you might prefer going for Kaggle rather than Google Colab because when you are training huge data set of models in machine learning, it would require huge amount of RAM. So for that, Kaggle might be better in that case, but generally both of them are cloud platforms, so doesn't have to go with either of them. It was the other unsupervised learning methods beside clustering. The one I said was association. That is just a broad category, clustering and association. Then, if we just dive deep into it, then we get more stuff based on what criteria we select the model to predict. So, the first thing that we need to see is the data actually. We need to see the data. If the data is labeled, if it goes well with supervised learning, then we'll go for supervised learning. And if it's not labeled, we need to go for unsupervised learning, we'll go for unsupervised learning. And that again, the thing is, it depends on the data basically. We need to see the data first and then we have to decide because there's also another type of machine learning called reinforcement learning. So all that depends on the data that we have or the problem that we want to solve or the type of insights that we want to get. So as soon as as far as we clear that out, we have a clarity on that, then we can decide what model to select and all. Okay, then. Thank you all for joining. It was wonderful to have you all. Have a great day. Bye bye. Just a okay. I just got another question. I'll just take this last question. What model can I pick if I have a large data set? So as I already answered previously, it depends on the type of data set that you have. You cannot just pick up any data set and pick up any model for it. Sometimes you might be able to do it, but you won't get a good accuracy. And you should at least get an accuracy of 80 plus to have a well-trained model, to call it a good model, at least a working model, basically. Okay, then. Thank you. Any further questions, you can definitely take up in AMA sessions. Don't miss them out. And yeah, that's it. Thank you, everyone. Bye bye.